The ocean, a vast, teeming world that holds the key to our planet's health. Yet beneath the waves, a silent crisis is unfolding. This is ocean acidification, a threat to marine life as we know it. Driven by our own actions, it is a stark reminder of our interconnectedness with the natural world. As the Earth's climate changes, the ocean absorbs increasing amounts of carbon dioxide from the atmosphere. This might seem beneficial at first, preventing even faster warming of the planet. However, this absorption comes at a cost, altering the very chemistry of our seas. The consequences of this change are far-reaching, impacting a vast array of marine life. From microscopic plankton to majestic whales, the delicate balance of the ocean ecosystem is under threat. Understanding this crisis is crucial, for its impact extends far beyond the ocean's depths, reaching our own lives in profound ways. We must act now with urgency and purpose to mitigate this silent crisis. The fate of the ocean, and indeed our own, hangs in the balance. Ocean acidification is a tale of chemistry. As carbon dioxide dissolves in seawater, it sets off a chain reaction. This increases hydrogen ions, decreasing the pH of the water. This gradual shift towards acidity is called acidification. The pH scale measures acidity or alkalinity. Seawater is naturally slightly alkaline, around 8.1. Since the Industrial Revolution, ocean pH has dropped by about 0.1 units. This small change has significant consequences for marine life. Coral reefs, often called the rainforests of the sea, are among the most vibrant and diverse ecosystems on Earth. These underwater cities, built by tiny animals called polyps, provide shelter, food, and breeding grounds for countless marine species. Yet these vital ecosystems are particularly vulnerable to ocean acidification. Corals, like many other marine organisms, rely on calcium carbonate to build their skeletons. As the ocean acidifies, the availability of carbonate ions decreases, making it harder for corals to build and maintain their intricate structures. This weakens the reefs, making them more susceptible to damage from storms, diseases, and other stresses. The impact of acidification on coral reefs is already evident in many parts of the world. Slower growth rates, increased susceptibility to bleaching events, and reduced recruitment of new corals are all telltale signs of an ecosystem under stress. The loss of coral reefs would be devastating, not only for the countless species that depend on them, but also for millions of people who rely on these ecosystems for food, livelihoods, and coastal protection. Though microscopic in size, plankton play an outsized role in the ocean's ecosystem. These tiny organisms form the base of the marine food web, supporting a vast array of creatures from small fish to giant whales. They are also vital to the planet's oxygen production, generating a significant portion of the air we breathe. Ocean acidification poses a serious threat to various types of plankton. For instance, coccolithophores, a type of phytoplankton with calcium carbonate plates, are particularly vulnerable to changing ocean chemistry. As the water becomes more acidic, their delicate plates dissolve, impacting their ability to photosynthesize and survive. The decline of these crucial primary producers could have cascading effects throughout the food web. With less plankton available, fish and other marine animals that depend on them for food would face dwindling resources, potentially leading to population declines and ecosystem imbalances. The impact of acidification on plankton highlights the interconnectedness of life in the ocean. Even seemingly small changes at the base of the food web can have ripple effects that are felt throughout the entire ecosystem. Section 5, Troubled Waters, Fish in a Changing Sea. Fish, from the smallest goby to the largest shark, are an integral part of the ocean realm. They play vital roles in the food web, regulate nutrient cycles, and contribute to the overall health and balance of marine ecosystems. Yet ocean acidification is throwing a wrench into their underwater world, affecting their behavior, development, and survival. Studies have shown that acidified water can impair the sensory abilities of fish, particularly their sense of smell, hearing, and ability to detect predators. This disruption can make it harder for them to find food, avoid danger, and navigate their surroundings, ultimately impacting their survival. Furthermore, acidification can affect the growth and development of fish larvae. In some species, exposure to more acidic water has been linked to deformities, reduced growth rates, and decreased survival rates, potentially impacting the replenishment of fish populations. The impacts of acidification on fish are complex and vary depending on the species and their specific vulnerabilities. However, the overall trend is clear. A more acidic ocean poses significant challenges to the well-being of these vital marine creatures. Section 6. A ripple effect from ocean to our tables. The consequences of ocean acidification extend far beyond the ocean's depths, reaching our own lives in significant ways. As a species intrinsically linked to the sea, humans rely on the ocean for food, livelihoods, and even the air we breathe. The decline of fish populations due to acidification poses a serious threat to global food security. Millions of people around the world depend on fish as their primary source of protein, and the fishing industry provides livelihoods for countless others. The economic and social consequences of dwindling fish stocks could be devastating. Furthermore, the loss of coral reefs, also fueled by acidification, would not only impact tourism and coastal livelihoods, but also reduce natural coastal protection from storms and erosion. The economic and social costs of such losses are difficult to overstate. Ocean acidification is a stark reminder that the health of the ocean is inextricably linked to our own well-being. What harms the ocean ultimately harms us all. Section 7. An ecosystem in peril, biodiversity at stake. The ocean, teeming with life in its myriad forms, is a treasure trove of biodiversity. From the smallest microbes to the largest whales, the interconnected web of life in the sea is a testament to the power and wonder of evolution. Yet, this delicate balance is under threat, with ocean acidification acting as a major driver of biodiversity loss. As acidification intensifies, it creates a domino effect, impacting species at every level of the food web. The decline of plankton, the foundation of the marine food chain, sends shockwaves through the ecosystem. Predators deprived of their prey face starvation, and the delicate balance of life unravels. The loss of biodiversity, exacerbated by ocean acidification, weakens the resilience of the entire marine ecosystem. It makes the ocean more vulnerable to other stresses such as pollution, overfishing, and climate change, further accelerating the decline of this precious resource. Protecting marine biodiversity is not just an ethical imperative. It is essential for the health of the planet and our own survival. A diverse ocean is a resilient ocean, better equipped to withstand environmental changes and continue providing the vital services upon which we all depend. Section 8. Turning the tide: actions for a healthier ocean. The challenge of ocean acidification may seem daunting, but it is not insurmountable. With collective action, we can mitigate its impacts and chart a course towards a healthier ocean for future generations. The most crucial step is to address the root cause of the problem: carbon dioxide emissions. Transitioning to a low-carbon economy powered by renewable energy sources is paramount. By reducing our reliance on fossil fuels, we can slow the rate of ocean acidification and give marine life a fighting chance to adapt. Protecting and restoring marine ecosystems, particularly those that play a vital role in carbon absorption, such as seagrass beds and mangrove forests, is another important strategy. These ecosystems act as carbon sinks, absorbing carbon dioxide from the atmosphere and mitigating the effects of acidification. Furthermore, sustainable fishing practices, reducing pollution from land-based sources and establishing marine protected areas can help enhance the resilience of marine ecosystems and make them better equipped to cope with the challenges of acidification. Section 9. Our shared future, a plea for their blue planet. The ocean, a source of wonder, sustenance, and life itself, stands at a crossroads. The choices we make today will determine its fate and, by extension, our own. Ocean acidification, a consequence of our own actions, is a stark reminder of our interconnectedness with the natural world. The time to act is now. We must heed the warnings from the deep, recognize the urgency of the situation, and take bold steps to mitigate this silent crisis. By embracing sustainable practices, reducing our carbon footprint, and protecting marine biodiversity, we can turn the tide and ensure a healthy ocean for generations to come. The future of the blue planet, and indeed our own, rests on our collective action. Let us rise to the challenge, embrace our responsibility, and become stewards of the ocean, for its sake and for ours.